Hello, welcome to my Lab 2 presentation. Introduction. Found a trajectory of a projectile and compared it with its expected values. I used Tracker to figure out the object's trajectory at exact times, and I used code to figure out the expected trajectory. The purpose is to compare the observed and predicted motion of a moving object. The experiment. I recorded a video of throwing an object from a height. I uploaded a video to Tracker and found the observed values. I used the initial velocity from the video and I found the expected values, and I charted the expected and observed values on a graph to see the differences. Here's a video of my motion.
Okay, you're good. Okay.
The main ideas. Motion. It's the indication of a change in position. Momentum, which computes the change in motion. Position, which indicates where a vector is on a coordinate plane. And velocity, it indicates the speed and direction of the motion. Its change means an interaction has occurred. Now, the physics principles. Newton's second law, the momentum principle. It's an object's acceleration is proportional to its net force, and it says that it's inversely proportional to its mass. Kinematics of projectile motion describes how an object moves in the air. Drag force, a resistive force that pushes the object upwards, and speed increases when the drag force increases. Terminal velocity, an object reaches maximum speed when its net force is zero, and it has to be an object falling through air and when the drag force equals gravity. Physics models, the vector update formula and the vector average formula, and then using the vector average formula, you find the position update formula, and then the force of gravity is represented by the y component, negative mass times gravity, and F drag is represented with v hat, which is the unit vector of velocity, and b is the proportionality constant, and F drag is equal to negative b v squared times v hat. The Newton's second law of motion, which combines both the velocity and position update formula and the gravity on Earth. Now, here are the results. Now, the similarities and differences are the observed value has a more constant velocity than the expected values. The difference between the F drag and F grav is minimal due to the F drag being small, and the expected value does not show a constant velocity unlike the observed values. The system and surroundings. The system is a crumpled ball of paper, and the surroundings are the outside forces, which is the gravity and air, and included with the air is the drag force. Now, here's the code used. And as you can see in the code, the ball's velocity is the velocity update formula, and the ball's position is the position update formula. And delta t is represented by t equals t plus delta t, and delta t is 0.033. And then here, as you can see, is the output of the code. The left side shows the fnet when fnet only equals fgrav, and the right side shows the fnet when it equals fgrav plus fnet. No, fgrav plus fdrag. Now, the initial conditions are the motion is two-dimensional. It accesses both the x and y direction to compute the velocity. The mass is 3.45 grams, and the gravity is 9.8 meters divided by second squared, and delta t, which is 0.03 seconds. Now, the sources of error are using the wrong proportionality constant b value, or the position tracking errors due to video lag or blurry screen, which causes time errors. Now, do models predict a terminal velocity? The terminal velocity has not been modeled in this experiment due to the drag force being minimal, and we can find out with the drag force and gravity Fnet being very similar. And to find a terminal velocity, you need to throw the ball from a higher height or use a heavier object. Now, what if the object were thrown straight up, it would have taken longer to reach the ground. The object will take more time to reach the ground because initially the gravity will decrease. Then, from the decrease, the gravity will then increase and come down, and then from a higher distance, it will take longer to come down. Now, using Newton's second law momentum principle formula, which incorporates a velocity update and the position update, we can see an increase in velocity will happen due to gravity initially decreasing, then suddenly increasing, and the increase in velocity will increase the final position, and due to the increase in position, the time will also increase. Thank you.